Hello friends, Standard 12 Chemistry, Unit 10, Haloalkanes and Haloarenes, Part 8. Last time we discussed about mechanism of SN1 reaction and SN2 reaction. Today we are going to learn the comparative study of SN1 reaction and SN2 reaction. Here the points are, points number 1, it's order of reaction. First of all, order of reaction. For SN1 reaction, it's order of reaction 1, and for SN2, order of reaction 2. Number 2, molecularity. First of all, what is molecularity? The number of ions or molecules that take part in the rate determining steps. Again, number of ions or molecules that take part in the rate determining step. Rate determining step, RDS, is known as molecularity. For SN1 reaction, its molecularity is 1, and for SN2, 2. Point number 3, that is its rate of reaction. Rate of reaction. SN1 reaction is independent from the concentration of nucleophile. Here for SN1 reaction, the K into concentration of alkyl halide into concentration of nucleophile. An SN1 reaction is independent from the concentration of nucleophile. That's why we can write here equal to K concentration of alkyl halide only. While in SN2 reaction is dependent on the concentration of nucleophile. That's why we can write here concentration of alkyl halide and concentration of nucleophile. Then after, which type of alkyl halide is most favor the SN1 reaction? That means here alkyl halide RX. Here for SN1 reaction, tertiary alkyl halide is most favor, then secondary, then primary, and then methyl. While in SN2 it's opposite, methyl, then primary, secondary, and tertiary. Point number 5, which type of solvents are used? In SN1 reaction, most of the polar solvents are used, like water molecule, alcohol, acid, etc. While for SN2 reaction, most of the non-polar solvents are used. For example, here benzene, carbon tetrachloride, carbon disulfide. This is the example of SN2 reaction. Number 6, which type of intermediate is formed? In SN1 reaction, trivalent carbocation is formed, as we have discussed earlier already. Trivalent. Okay, this is the stable carbocation and can be rearranged. While in SN2 reaction, pentavalent carbon is formed. Pentavalent carbon. It is unstable and cannot be rearrangement. Okay, and last, the product. In SN1 reaction, mixture of two product we get, while in SN2 reaction only one product is formed. So this is the comparative study of SN1 and SN2 reaction. Now let's see very most important part, that is plane of symmetry, stereo aspects of nucleophilic substitution reaction. Stereo aspects of nucleophilic substitution reaction. Here optical activity, then after chirality, retention, inversion, racemic mixture. Okay, so let's see here plane of symmetry. Before we are going to study the plane of symmetry, we have some idea about isomerism. As we know that the compound have same molecular formula, but differ from their physical and chemical properties. These are called isomers, and these phenomena are called isomerism. Okay, here the two types of isomerism. Number one, structural isomerism, and number two, stereoisomerism. Okay, structural isomerism we studied in 11th standard. Let's see stereoisomerism. First of all, stereoisomerism. Here this isomerism is caused by different arrangement of atoms or groups, in a space, and this phenomena is called stereoisomerism. Stereoisomerism, here number one, geometrical isomerism, and number two, optical isomerism. Geometrical isomerism, GI, and isomerism, optical isomerism, OI. Now let's see what is optical isomerism and what is optical isomer. Optical isomers, that means they have ability to rotate the plane polarized light, and this property is often referred as optical activity. Some of the organic compound have to rotate the plane of polarized light. This compound is said to be optically active. Now let's see the basic idea about optical activity. Optical activity. Ordinary light that vibrates in all directions. Most of the ordinary light that vibrates in all directions. is passed through Nicol prism. Nicol prism is made up of calcite, CaCO3, calcium carbonate. Light is found to be vibrate in only one direction. Only one direction. And it is said to be polarized light. It is said to be polarized light. Some organic compound, a solution of some organic compound have ability to rotate the plane of polarized light. And this compound is said to be optically active compound. This polarized light is rotated to the right side or left side, is the eyesight. So basically the beam of polarized light is rotated to certain degree of either to the right side that means clockwise manner. It is said to be dextro-rotatory. Indicated by small d or plus sign. If it rotates to the left side, that means anti-clockwise manner. It is said to be levo-rotatory. It is indicated by small l or minus sign. Okay. If plane polarized light PPL plane polarized light, in short we can say PPL, is rotated to the right side or clockwise manner, it is said to be dextro-rotatory, or left hand side, it is said to be levo-rotatory, indicated by negative sign. Now let's see plane of symmetry. A plane which divides an object into two halves. Suppose here the circle is divided into two halves, and it is said to be plane of symmetry because it's divided into same two part. Suppose here it's a square, it is divided into same half. Okay, so it is said to be plane of symmetry. object that lacking of plane of symmetry. Object that lacking of plane of symmetry. That means it is said to be dissymmetry. Or chiral or chiral. While symmetric object, symmetric object, it is referred to as a chiral. It is referred to as a chiral. And dissymmetric or object lacking of plane, it is said to be chiral object. Okay. Now let's see the basic difference. Right hand is a mirror image of left hand. Our suppose this is the right hand. Okay, it is the mirror image of the left hand, so it is said to be as chiral object. Okay, and this left hand is mirror image of right hand. Okay, so it is said to be as chiral object. So right hand, so mirror image of left hand. Okay, another example, feet, shoe pair, ear, these all are does not have plane of symmetry. Because this symmetry is very most important to study the chiral carbon atom or asymmetric chiral carbon atom. Let's see chiral carbon atom or asymmetric. Asymmetric, that means it's a Latin word that means without symmetry. It is said to be without symmetry. Okay, now let's see what is chiral carbon atom. Carbon atom which is bonded to four different group or atoms, is called chiral carbon atom. Here this carbon atom is sp3 hybridized carbon atom. This is the main condition to be as chiral carbon atom. Number one, it must be sp3 hybridized carbon, sp3 hybridized carbon. And second condition, all the groups or atoms, four groups or atoms are must be different. That means A is not equal to B is not equal to C is not equal to D. Here carbon atom which is bonded to four different groups or atoms is called asymmetric or chiral carbon atoms. Let's understood the by example. Here the carbon methyl group to one ethyl group and CH2 CH2 CH3. So here for example, with this carbon is sp3 hybridized carbon. With this carbon, methyl group is ethyl group, this propyl group, and this hydrogen. So these are the here three groups and one atoms. These are the difference which is attached with this carbon. So it is said to be chiral carbon, and it is indicated by asterisk sign. Asterisk sign. Okay. Two conditions is fulfilled. Number one, it is sp3 hybridized carbon, and four groups or atoms are different. So it is said to be this is a chiral carbon. Another example, 2-hydroxy propanoic acid CH3 CH on second position, 2-hydroxy propanoic acid. So in this molecule we have three carbons. Number 1, number 2, and number 3. Which carbon is said to be as chiral carbon atom? Let's say one by one. Here this carbon is attached only with one carbon atom, so it is not fulfill the four different groups, same as methyl and rest of the second carbon. Here this carbon is attached with one hydrogen atom and OH group on left hand side, COOH on right hand side, methyl group. So these are four different groups. So it is said to be second carbon is one chiral carbon. So this molecule has one chiral carbon atom. This molecule has also one chiral carbon atom. Now let's see here CH3 CH2 Br, ethyl bromide. Let's check the chiral carbon atom is present or not. We have two carbons, number 1 and number 2, numbering from here 1 2. So on first carbon, two hydrogen atoms here and one methyl. So it is not it's a achiral. Okay. Now let's check the another this, and here CH2 Br. So these have all the three hydrogen atoms and are same, so it is said to be achiral. Okay, this is the structure of ethyl bromide, because here two hydrogen atom is same, here in this case three hydrogen atoms are same, so in this case this said to be achiral. Does not have four different atoms, does not have four different atoms or groups. So it is said to be as a chiral. Let's see another example. Suppose here CH3 CHO, CH3 CHO. For this condition CH3, so this carbon has only 3 different groups, and our condition is that it must have 4 different groups or atoms. So it is not chiral but a chiral molecule. And second thing is that this carbon is sp2 hybridized carbon atom. So for that, one thing is not that sp2 hybridized carbon atom cannot be chiral. Another example, suppose it is carbocation, free radical, carbon carbon double bond, carbon ketone, or acid derivative, or nitrile in imine and oximes. These all are cannot be chiral molecules. Okay, now let's see the structure of glucose. 1 2 3 4 5 and 6, CH2 OH OH H H OH. This is the structure of glucose. This carbon is not chiral carbon. So for this carbon, let's see here, this carbon, one hydroxyl group, here hydrogen, carbon, rest of the other the molecules. So this is chiral carbon, same as here, same as condition is here, because and here, because here this carbon is attached with this structure is OH H and rest of this structure. This carbon is attached with hydrogen on right hand side, OH in this structure. So 1 2 3 4, so glucose has 4 chiral carbon atom, this sign indicated by asterisk sign. Now let's take an example about fructose. This is the structure of fructose, CH2 OH, and one ketone group is present, another OH, 1 2 3 4 5 and 6, you have 6 carbon. Okay, this is the structure of fructose. See here, is not chiral carbon, is also not chiral carbon. Here the same condition is here, this chiral carbon, because one hydroxy here, 1 2 and is 3 and number 4. Okay, so this chiral carbon. Let's check another, this is also chiral, because 1 2 rest of the 3 upper structure and lower structure is differ from each other, so that's why it is chiral. And here is hydrogen, oxygen, CH2H, and rest of the upper part of the carbon is differ, so that's why 1, 2 and 3. For this carbon it is not chiral carbon because two hydrogen atoms is here is same, so that's why 1, 2 and 3. So these are three chiral carbon atom. Okay, now let's see another example, glycerol. 1, 2, 3 propantriol, CH2 OH, CH OH, CH2 OH, 1, 2, 3 propantriol. Here let's check the chiral carbon. Here two hydrogen atom is same, so because of this is not chiral carbon. Same condition is here, so let's check here, OH, CH2 or OH, and here so here this is also the same, it is said to be a chiral molecule. Okay, now let's see this structure, how many chiral carbons are present. Here this is methyl group, each corner that represents the CH2 group. Okay, this represent, and this carbon is bonded with oxygen atom, so it is said to be ketone, is CH2 group and CH group, and this is methyl group. Okay, so now let's check here, is methyl group, it is not chiral carbon, is not fulfill also the requirement, basic requirements about sp3. It is sp3, but it does not have four different atoms. Let's check here the one methyl linkage is here. This is the chiral carbon because this methyl linkage is differ, this the pathway is differ, and here the CH2 group, so these have and one hidden hydrogen atom, and this is chiral carbon. This is not chiral carbon because it is sp2 hybridized carbon. This carbon is not chiral carbon because this have two hydrogen atoms. Let's check another, here this chiral carbon because 1, 2, 3 third linkage is differ and one hydrogen is here, so it is said to be chiral carbon. So this molecule has two chiral carbon atom. So now let's see the another, how many isomers are present, number of isomers are formed. It is said to be 2 raised to n, where n that is number of chiral carbon atom. In glucose we have already discussed 4 chiral carbon atom. So in glucose number of isomers 2 raised to n 2 raised to 4, because 4 chiral carbon atom, it is said to be total number of isomers present in glucose 16. Here in 16 8 are dextrorotatory and 8 are levorotatory. Okay, this is called racemic mixture. Total racemic mixture is made up of 8. For fructose 3 chiral carbon, number of isomers equal to 2 raised to n equal to 2 raised to 3, it is said to be 8. Mixture 4 dextrorotatories and 4 levorotatory. Okay, suppose here in this molecule how many isomers are to be formed. So 2 raised to 2 is equal to 4. 4 isomers are present in this molecule. Let's see for cyclic compound. Here this carbon, it's a chiral molecule because this here CH2 and here CH2 is, so it is said to be 2 degree, so it's a chiral molecule. Let's see another example. This is the dash wedge with chlorine. So this carbon is said to be chiral because this on right hand side or left hand side all the groups are different, and hidden hydrogen atom on rear side of the molecule hydrogen. So these all are different groups, so it is said to be one chiral carbon atom. Here on left hand side or right hand side the geometry is different because here CH2 and one hydrogen atom is hidden, and this, so all groups are or atoms are different, so it is said to be chiral carbon. And here this is also chiral carbon because here the geometry is differ, hydrogen atom is hidden, the same condition is here. So they have 2 chiral carbon. Now let's see here. Here in this case is not chiral center, is not chiral center. Okay, this chiral center because one hydrogen atom is attached here. It's not chiral carbon, is also, it is said to be only one chiral carbon. Okay, one by one you can check here which carbon is chiral or not. So for chiral carbon, the main basic two conditions are fulfilled. Number one, as it must be sp3 hybridized carbon atom, and number two, carbon atom bonded with four different atoms or group. So it is said to be chiral carbon atom. Okay friends, so next time we will discuss another topic. Thank you very much.